Imagine waking up and finding out the city replaced, like every single water pipe in your neighborhood overnight.
Right, just completely swapped out.
Yeah, exactly.
Yeah.
Not a single jackhammer, no construction crew, nothing. And the really crazy part, they didn't replace those pipes for you.
Oh, no. Huh?
Yeah, they replaced them because this entirely new species of autonomous machines just moved in, and well, those machines require a completely different kind of water pressure.
That is, I mean, it's a wild thought, but that is exactly what is happening right now in the multi-billion-dollar data engineering industry. It is literally reshaping the entire internet as we speak.
It's crazy. And welcome to the deep dive. If you're joining us today, you are probably what we like to call the learner.
Always the best kind of listener.
Definitely.
Yeah.
I mean, maybe you are prepping for a massive tech strategy meeting, or maybe you're trying to figure out how to future-proof your data engineering career. Or, maybe you are just insanely curious about how the future of AI actually gets built under the hood.
Either way, you are in the exact right place. Because today we are tearing into the actual plumbing of the internet.
And that plumbing just underwent a massive overhaul, right? Like a multi-billion-dollar renovation that completely redefines how companies interact with their own information.
It really did. And to truly understand where artificial intelligence is going, you cannot just look at the shiny user interfaces or, the chatbot windows.
Right, the stuff everyone sees.
Exactly. You have to look at the pipes underneath, because that invisible architecture tells the real story.
So our mission today is to understand why the biggest, wealthiest tech companies on Earth are suddenly and aggressively changing how they handle data. And, why the old rules of data engineering are basically dead.
They really are. The foundation we've used for the last 15 years is just gone.
Yeah. And our sole source for this deep dive is this incredibly fascinating July 2026 article from datapro.news by Samuel Williams. It's titled, "The Warehouse Wars Are Over. The Real Fight is for Your Agents."
It is such a phenomenal piece of analysis, too. Williams completely cuts through all the product keynote hype, and, well, he simply follows the money.
Which is always the best strategy, right?
Always. Watching where these giant platforms actually spend their billions tells you absolutely everything about their real roadmap. Actions speak louder than press releases.
Okay, let's unpack this.
Yeah.
Because Samuel Williams highlights two massive financial acquisitions from 2025 that basically broadcast the entire industry's secret game plan.
Yeah, these were shockwaves when they happened.
For sure. So first, Databricks spent roughly $1 billion to buy Neon, which is a serverless Postgres company.
Right.
Then, just a few months later, Snowflake bought Crunchy Data, which is another enterprise Postgres outfit, for around $250 million.
And on the surface, for anyone who has worked in data architecture over the last decade, those purchases look like a complete contradiction. It goes against everything those companies have historically stood for.
I was reading that section and literally doing a double take. Because for our listeners who live in this space, you already know Postgres is the classic transactional database.
It's a workhorse.
Right. It is the workhorse running everyday application state. But for the last 15 years, the gospel, according to analytics giants like Snowflake and Databricks, was that you must maintain this strict, impenetrable firewall between your transactional operational systems and your analytical data warehouse.
That was the golden rule. You just don't mix the app data with the heavy historical crunching. You kept your transactional databases focused entirely on serving the user interface and processing immediate actions.
Just keeping the lights on in the app running fast.
Exactly. Then later, you moved copies of that data over to the warehouse for the heavy lifting, the historical trends, the business intelligence, all that.
So seeing these analytics giants suddenly buy up transactional databases, it's like a famous vegan restaurant suddenly buying a massive cattle ranch.
That is a perfect way to put it.
It's like, wait, this goes against everything you've been selling us. So why the sudden pivot?
What's fascinating here is the underlying shift in who, or rather what, is actually using these platforms now. The cloud data warehouse has quietly stopped being just a place where human beings go to run reports or look at dashboards.
Oh, wow. So it's not about humans looking at data anymore?
Not primarily, no. It has fundamentally transformed into the actual runtime environment where AI agents live and operate.
That is wild. We aren't building these systems for, human analysts looking at quarterly revenue anymore. We're building them for the machines that are actually doing the work.
Precisely. Think about the workflow. A human analyst writes a query, waits a few minutes, looks at a chart, and then makes a business decision maybe hours or days later. It is a very passive interaction.
Right. Humans can be patient, or at least we have to be.
Exactly. But an AI agent is active. It interacts with the world in real time. It needs to read the historical context, the analytic side, and immediately write a new action or update a record, the transactional side, in the exact same environment.
I see. So if the agent has to constantly jump back and forth between a separate transactional database and an analytical warehouse,
The friction just makes it completely useless. The latency kills the whole process.
and Williams drops this one statistic from Neon to prove just how fast this transition is happening, and it kind of blew my mind.
Oh, the 80% stat.
Yes. Inside Neon, over 80% of all databases were created by AI agents and code generation tools spinning up isolated environments on demand, not by human developers.
It's staggering. 4 out of every 5 databases in that ecosystem were spun up by autonomous software just because it needed a temporary sandbox for a specific task.
4 out of 5. I mean, think about the scale of that automation. But wait, let me ask you this. If we allow AI agents to instantly write to the same database the whole company uses for analytics, doesn't that risk massive corruption?
That is a very valid concern.
Like if an agent hallucinates, isn't it just writing garbage data directly into the central nervous system of the company?
And that is the exact reason why these platforms are acquiring companies like Neon. They desperately need the ability to instantly branch a database.
Branch a database, like how software developers use Git to branch code.
Exactly like that. A developer creates a separate copy, tests their changes, and if it works perfectly, they merge it back into the main code. If it breaks, they just throw it away.
Oh, okay.
Modern data architecture needs to do that exact same thing, but with massive live databases. The AI agent spins up an isolated branch of the company's data in milliseconds, runs its task, tests the outcome, and only commits a transaction if it passes strict validation.
So the agent gets its own private playground that looks exactly like the real database, and the core data stays perfectly safe.
Yes, and doing that requires an incredible amount of agility, which kind of brings up the technical bottleneck we were hinting at earlier.
Right, which I want to clarify because this makes so much sense now. So a human looking at a business dashboard can totally wait for a nightly data dump, right? The system processes everything in a big batch at 2 a.m., and it's fine.
Because the human is asleep anyway.
Exactly. But an AI agent is essentially the most impatient user on Earth. It relies on real-time state, which means the old way of moving data around completely breaks down.
You were talking about batch ETL, extract, transform, and load.
Yeah, batch ETL.
That was the traditional plumbing we used to move data from the transactional app over to the analytics warehouse. You extract the raw data, run it through a cleaning pipeline, and then load it in.
But that takes time.
A lot of time. That pipeline introduces severe lag, sometimes a few hours, sometimes a full day.
And Williams argues that this ETL lag is just lethal to autonomous agents, specifically because of things like vector retrieval. Can we actually break that mechanism down for a second?
I'd love to. I'm really glad you brought that up.
Because I think understanding how vector retrieval actually works really illuminates why these agents are so incredibly impatient.
Okay, so traditional databases look for exact keyword matches. If you search for the word happy, it only finds the exact word happy.
Right. Very literal.
It's extremely literal. But a vector database maps concepts in mathematical space. It knows that joyful and glad live in the exact same neighborhood as happy.
Oh, I see.
So when an AI agent processes a complex query, say, a customer complaining about a delayed shipment in a very specific, frustrated tone, the agent uses vector retrieval to instantly find similar historical situations and the corresponding solutions.
But, and here's the catch calculating that spatial neighborhood requires instant access to the raw current data.
Yes. The agent cannot wait for a nightly badge update to tell it where those new concepts moved based on today's customer interactions.
Because then it's working with old information.
Right. If the vector embeddings are stale, the agent's contextual understanding is completely broken. It will give a generic, unhelpful response because it literally lacks the real-time state of the business.
Which leads directly to the industry's new holy grail that Williams talks about, zero-ETL.
The absolute holy grail.
I was trying to picture how this functions compared to the old way. And tell me if this makes sense. Batch ETL feels like a journalist, reading a live court transcript, driving back to the office, writing a summary, and publishing it the next day in the newspaper.
Okay.
But zero-ETL is like the AI agent sitting directly in the courtroom, reading the stenographer's screen over their shoulder in real time.
That is a brilliant analogy. I might actually steal that. Zero ETL means your operational, everyday transactional data lands in the exact same open storage layer that your analytics and your AI models are reading from.
So no middleman.
Exactly. There is no pipeline to build. There is no secondary copy of the data that you have to nervously try to keep in sync. It just exists instantly for everything that needs it.
Okay, so if every single AI agent needs this unified, low-latency, zero-ETL setup to function properly, how are the big tech vendors actually responding? Because looking at the landscape Williams paints, it feels like everyone is suddenly converging on the exact same blueprint.
They absolutely are. Williams calls it the modern data singular.
The modern data singular. I love that phrasing.
The convergence is undeniable. If you look at the top 5 platforms, they're all marching toward identical architectural models. They're just wrapping it in different marketing jargon.
He lists them all out in the article. And the parallel is wild. So Snowflake has Cortex AI and Unistore. Databricks has Lakebase, which is powered by that Neon acquisition, and AgentBricks.
Google is wrapping BigQuery in Big Lake storage.
Right. And Amazon Redshift has decoupled with RA3. Microsoft Fabric is collapsing everything into one lake. It sounds like a ton of corporate buzzwords, but what is actually happening under the hood across all of these platforms?
Let's strip away all the marketing names. At a purely mechanical level, they are all adopting a decoupled architecture.
Decoupled meaning
Yeah.
separating things out.
Exactly. Historically, the storage of the data and the compute engine that queried the data were tightly bound together in one box. Now they are separating them completely.
Oh, I see.
The data simply sits in an open format in cloud storage, like Amazon S3 or Google Cloud Storage. Then multiple isolated compute clusters can hit that exact same data simultaneously.
So you can have a massive compute cluster running heavy historical analytics and a separate lightweight compute cluster handling the AI agent's real-time transactional updates.
Yep.
And they are both looking at the exact same storage bucket without stepping on each other's toes.
You've got it. That is exactly how they achieve the zero ETL holy grail without crashing the entire system. You have one open storage layer, transactional and analytical workloads sitting on top, an AI runtime layered over that, and a single governance catalog monitoring the whole operation.
Okay, well, here's where it gets really interesting, though. Because if they are all building this exact same decoupled architecture, you would assume they are practically identical commodities, right? Just pick one.
They would assume that, yes.
But Williams brings the receipts to prove they aren't,
Yeah.
citing this massive 100 billion row benchmark test.
The cost variance in that benchmark is something every tech leader needs to pay attention to immediately.
It is a massive discrepancy. So on this 100 billion row job, a specialized columnar engine processed the entire workload for under $20.
Pocket change, really.
Yeah. But that exact same workload on Snowflake cost about 32 times more. And Google BigQuery, using their on-demand pricing, came out over 1,000 times more expensive than the $20 baseline.
That is the kind of pricing model that leads to a surprise 5-figure cloud bill just because a junior engineer, or increasingly an autonomous AI agent, ran an unoptimized full table scan.
Just accidentally spending 20 grand in an afternoon, which brings up a huge question. If the cost difference is 1,000 times more massive, shouldn't a company still just pick the cheapest, fastest engine? I mean, $20 versus $20,000 is a board-level conversation.
This raises an important question, and it is actually the crux of Williams' entire thesis. Yes, avoiding a surprise 5-figure bill is crucial. Nobody wants that. But raw scan speed, the ability to crunch those 100 billion rows the absolute fastest, is no longer the primary constraint for the systems we are building today.
Okay, I'm struggling with that a bit. Fast is always good in tech, right? Why wouldn't we prioritize the absolute fastest engine?
Because context and pipeline latency trump raw query speed every single time now. Let's go back to the AI agent.
Okay, the impatient agent.
Exactly. If a query runs in 1 second on a specialized superfast engine and 3 seconds on a converged platform, that 2-second difference is just a rounding error. Nobody cares.
Right, 2 seconds is nothing.
But if that faster engine requires a separate data pipeline, that batch ETL we talked about, that introduces a 12-hour delay before the data is even queryable, the agent is paralyzed.
Ah, I get it now. Being able to scan ancient data incredibly fast is totally useless if the agent needs to make a decision based on an event that happened literally 5 seconds ago.
Exactly. Pipeline latency matters infinitely more than raw query speed. The binding constraint isn't how fast the compute engine goes, it's where your operational data already lives and how quickly the agent can access it without jumping through messy integration hoops.
So the traditional vendor bake-off, putting all the platforms in a room, running a benchmark speed test, and crowning a winner. That is an obsolete way to choose a platform.
Completely obsolete.
We need a new survival guide then. If speed and basic cost benchmarks aren't the ultimate deciding factor anymore, how do we actually navigate this landscape?
Well, Williams lays out 3 specific criteria that should drive this decision in the agent era. The first one is acknowledging ecosystem gravity and lock-in.
Ah, the dreaded vendor lock-in. It never really goes away, does it?
No, it doesn't. Convergence doesn't make lock-in disappear. It just changes its shape. The lock-in has officially relocated from the query engine itself to the broader ecosystem.
What does that look like in practice?
Well, if your organization relies heavily on Microsoft 365, Microsoft Fabric is going to exert massive gravitational pull because the integrations are all native. If you are deeply embedded in AWS, Redshift pulls you in.
You are basically choosing which orbit you want your company to live in, rather than just picking a standalone database.
Exactly. Which ties directly into his second criterion, governance as the control plane.
Governance. The word that usually puts everyone in the IT meeting straight to sleep.
I know. It used to be a boring back-office compliance feature, but now it is the most critical piece of infrastructure you own.
Really? The most critical.
Absolutely. Think about the converged architecture we just outlined. You have transactional records, analytical tables, vector embeddings, and autonomous AI agents all interacting on one single storage layer.
Right, it's all happening in one place.
So imagine an AI agent tasked with optimizing your global supply chain. It suddenly decides to halt a massive multi-million-dollar raw material order.
Oh.
If your governance is weak, you cannot trace exactly which table, which outdated vector embedding, or which historical transaction informed that decision. The agent essentially becomes a black box making massive financial decisions.
That is terrifying. If you can't trace the lineage of the data the agent used, you can't debug the AI. It's basically flying blind with the corporate credit card.
Exactly, which is why tools like Snowflake Horizon, Databricks Unity Catalog, and Microsoft Purview are taking center stage right now. They are the control plane.
They keep track of everything.
They track who or what machine touched a record, what specific policy applies to it, and the full lineage of every single automated decision.
Okay, so we have ecosystem gravity, we have governance as the central control plane. What is the final criterion for surviving this massive shift?
Open formats. This is the ultimate hedge against that ecosystem lock-in we talked about. You need to ensure your platform has native support for open table formats like Apache Iceberg and Delta Lake.
I see. That's like keeping your corporate savings in cash instead of casino chips.
Oh, I like that.
Right, because if you store your data in a proprietary format, which are the casino chips, you can only play at their tables, using their query engines, strictly by their rules.
Exactly.
But keeping your data in an open format like Iceberg, well, that gives you the freedom to walk out the door, cash in hand, and point a completely different compute engine at your data tomorrow if a better option comes along.
That analogy hits the nail right on the head. In a market moving this rapidly where billion-dollar acquisitions happen overnight, the option to change your mind without migrating petabytes of data is worth real money.
Flexibility, survival.
It is. Knowledge is most valuable when it's applied practically to protect an organization's future. Demanding open formats is how you protect yourself.
So what does this all mean? Like if we bring this all the way down to the listener's daily life, their career trajectory, their Wednesday morning stand-up meetings.
Yeah, the real-world impact.
Williams offers a really sharp warning about where human value is heading in this space, doesn't he?
He does, and it is a sobering reality for a lot of engineers. The specific skill of tuning a single data warehouse to win a query speed race, that skill is depreciating rapidly.
Because the machines can do it better.
Exactly. By 2026, the platforms are automating that optimization. The machine is making the query fast on your behalf.
Which means the engineer who only knows how to write a slightly faster SQL query is essentially becoming a commodity.
Unfortunately, yes. But on the flip side, the real value, the appreciating asset in the job market right now, is the person who understands the entire board.
The big picture.
The person who can design and govern this unified data-to-AI control plane.
The architect in the room.
The architect. The person who understands where the transactional state sits, how the vector embeddings update in real time, how the agents interact with those isolated branches we discussed, and who is ultimately accountable for the governance lineage.
Wow.
The warehouse wars are over. The fight now is about who gets to be the operating system for your AI agents.
We have covered incredible ground today. I mean, we started with the sheer irony of analytics companies buying unglamorous transactional databases.
The vegan restaurant buying the cattle ranch.
Exactly. We unpacked the mechanics of why ETL pipelines completely break real-time vector retrieval, and we laid out a new survival guide for choosing platforms based on governance and open formats, rather than just, raw benchmark speed.
It's a whole new world, and it all circles back to one fundamental truth. The infrastructure is no longer just serving us. It is serving the autonomous systems we are building.
It really is. And I want to leave you, our listener, with a final thought to mull over. We talked earlier about that mind-blowing statistic from Neon, that over 80% of their databases are now being spun up on demand by AI agents, completely bypassing human developers.
Right.
So, if autonomous agents are already dynamically creating 80% of our database environments today just to do their jobs, how long until those same exact agents realize they can get a slightly better compute price on a completely different cloud provider?
That is a profound implication.
Right. How long until an agent independently migrates your company's entire data infrastructure from AWS to Azure at 3 in the morning simply because it found a micro-optimization in compute pricing and had the autonomy to branch the data and move it?
It's going to happen.
When the plumbing is entirely code and the agents write the code. Who's really managing the data center now? Think about that the next time you turn on the tap and the water pressure feels just a little bit different. Thank you so much for joining us in this deep dive. Keep questioning the old rules, keep learning, and we'll see you next time.